So I've got that running. I've been buying.
They're using Visual Studio, you say?
Yeah.
He's been playing in Visual Studio, UDP and Visual Studio.
You didn't get my message, did you?
Which one's that?
Well, I have an update today.
Oh.
I use Visual Studio too.
Wow.
Which language you programming in?
C#.
C#?
Yeah. Well, it's the Wemos D1 Mini on the microprocessor. Yeah. But the web service is C#. And then I did like another query. I got my sump up on the web. That's what it comes down to. And then I use C# for the query too. And it works.
Cool. So let's see. I agree pretty much. My project this week was to get the drive to work, and I got the drive to work with 24 volts, and I was able to. Oh, let me show you. Boing. This is the TCT.
Whoa!
Oh, wow. It goes work and it's rolling
That's
down
as far
the
as it will
driveway.
go.
Oh, is that right? Well, journey of 1,000 miles then.
So what I've determined, it took me $100 worth of batteries. I got 2 car batteries spares for my cars, and put 24 volts on it, and I think it's got plenty of torque. I need to change the ratio, gear ratio, to improve the gain, the transmission ratio, increase it so that I get more torque. I should have 4 times the torque.
With 2 car batteries, so that can drive a car, a real car.
Oh yeah. Well, the thing draws 5 amps, man. It's only a 540 cold cranking amp battery, not 2 of them.
You know the batteries are used for UPS. They're 12 volt.
Yeah.
I don't even know what
What
the
is the
amp
UPS?
hours.
Joe.
There's a.
Joe kind of thing.
I probably got 10, 15 of them.
How
Yeah.
much longer is your driveway?
It's about 100 foot altogether,
Okay.
and that's about
30 feet, 25
that's
feet?
about 10, 15 feet
Oh,
there.
15, okay. You got a ways to go.
You have lead acid batteries?
Yeah.
They should have ran that thing all the way down driving.
Well, it's not the
Not the
battery. It's the and it's only a 100-watt motor. That's nearly nothing. It carried him. He was claiming last week that this 100-watt motor carried him around. So I should be able to carry that around. I just got to get the ratio, the gear ratio correct. I am not delivering torque to the wheels. And you can tell, I could tell, I've been having tinkering with this for a week, or for a couple of days anyway. And I could see it. It looked like it was, had plenty of torque. It pulled the motor out of its mounting one time. I said, man, that thing does have torque. It's just not delivered in the right, to the wheels properly, in appropriate ratio. I'll fix that. I think I'll be good to go.
Is that the max speed that you had it at right there, or is that?
But that's max speed.
Because it doesn't need to go even half that, does it?
No. I don't want it to go that fast, actually. And that's when I increase the ratio, it'll reduce the speed. It'll be much slower, which is fine. I don't want to be driving, 150 pounds of trash cans around. So that's that. And let's see.
That'd be a big week, 150 pounds, wouldn't it?
Yeah. But that's the max. But, it could happen. I'll be going from I have a 16 tooth sprocket and a 52 tooth sprocket. Currently, I'll be going to a 7 tooth and an 80 tooth sprocket.
So basically, you're at 3 ratio, and you're going to go to a almost 11.
That's
11.5?
4.33 going to 12.857. Currently it's 4.33 and it'll be going to 12.857. So that should give me, those batteries are heavy. I'm suspecting they're about 60 pounds just for 2 batteries.
That'd be a lot of
And like
garbage.
Ray was saying, I got a gel cell that'll probably pull a thing. If it's only pulling 5 amps, I think a gel cell will probably do it. These are two 540 co-cranking amp batteries. So
How'd you get 4.33 and 12.857?
I divided.
52 divided by 16 is
4.33.
no.
4 times 16, 64,
No.
32,
64.
Well, you're at 3 something. So 3.1, 3.2. And then your 7 to 80 is only going to be 11.2, 11.3, something like that. I'm without doing the math now. So
52 by 16, 3.25.
Huh, how did I do that? My calculator.
Magic.
Magic.
Yeah.
Yeah, 11.4.
Can't blame it on the library.
That's
That was a calculator, that's it.
11.42, 11.43.
Okay, my numbers are off. But the ratio between them looks like that should hold.
yeah, it's still, you're getting 3 times better performance. Or it'll drop your speed to a third, triple your torque.
It doesn't need to go fast.
No,
It just needs to go.
and that's why I said earlier. It's like it doesn't even need to go half that speed, which is, I think you're going to find there.
Yep.
And
that was my intent all along. In fact, I look at much smaller motors. In fact,
100 watt, you might get away with like a 60 or 70 watt, depending on the speed that you're.
I'm thinking this may actually do it, and that's a kid's toy drive, and that motor there is pretty.
Is it like a Barbie car or something?
Yeah,
That's
it's
how
a
it
Barbie
works.
car motor that, what's his face brought in.
For like a 3-year-old, 4-year-old?
Yeah, I think eventually we'll be able to go to that. And those motors are relatively cheap. If I can find that particular motor with the gear ratio in it, it'd probably be fine.
My
But
son
he
has
took it out of
a
a Barbie
4-wheeler, and on one charge on the normal battery, he can ride it for 40 minutes
Long
pretty
time.
easily.
Cool.
And I see those,
Those
see them by the road, side of the road all the time.
How much does
Yeah.
your son weigh now?
38 to 45, 40 pounds.
How old is your son?
He just turned 4 a little ago.
Or,
A couple
yeah.
weeks ago.
I used to get twins in one of those cars.
The Barbie Jeep,
Yeah.
twins right next to each other. Yeah.
And
Oh,
that's-
my uncle, he cut out the back end of the Barbie Jeep and he dropped a large car battery into it. That way, at the end of the day, he would pull it over into the garage, hook it up on the charger, and then when they wanted to drive it, they could drive it for hours.
Oh, yeah.
And hours. Oh, yeah. My nieces, and they could drive this thing for hours and hours, and he didn't have to worry about, the stupid little battery.
Because they're usually pretty flimsy. I went through that phase too.
And I kept telling him.
The kids would wear out before the car would wear.
Yeah, because I've got kids, and they were at that age and everything. I remember seeing kids pushing their Jeeps and cars down the sidewalk because the battery died. So,
I remember kids just looking at it, hitting it with a stick and walking off.
Yeah.
get mad.
Go back to the big wheel.
But, no, my dad, I guess some friend of his replaces UPS batteries for the hospital, and they have to do it every year. And the old batteries are plenty good.
Yeah.
So I got a couple boxes of batteries for free.
Oh, cool.
So
Buddy, old pal.
come get a couple. You're welcome.
All right. I've got one new one. If if they have enough current, that'll be fine if I can get by with that motor or whatever.
I think you could, at least for testing, to 30, 50 pounds.
I was having trouble with the torque, so I wanted to make sure I had enough horsepower, and I absolutely did.
Yeah.
Enough battery in it behind it. So
how
here's
is your, sorry, I was gonna say, how is your amplifier for delivering voltage to the?
this thing is delivered. You know, it doesn't touch it. I can plug it directly into the battery, or I can run it through the drive, and it's the same difference. There's no difference. So
There's,
far,
what do you mean by there's no difference? There's no loss? There's
no loss.
No overheating? What do you mean?
No overheating, no loss. It's only 5 amps, so
okay.
it shouldn't. At 43 amp, it shouldn't touch it. And it so far.
So the load is only 5 amps, but the driver is capable of doing 43 amps.
Supposedly, okay. Theoretically.
Blazing hot, on fire with.
And this is the this is just the fob control, the 4 relay fob control and the drive and Uno, and that's it on that little breadboard. That's the propulsion system.
What's the breadboard?
Just a breadboard
Right
to
here.
interconnect. This is the breadboard.
Oh, that's the
See,
breadboard.
so what we'll be able to do is we'll be able to get you to at 8266 and use your cell phone as the controller.
Yeah.
Get rid of
This
the
is
box.
just phase 1. This is the cheap model. This is El Cheapo, step 1 manual. Yeah, and then B is forward and B is backwards. And then A and B, A and C will be left and right. Next unit is direction. I've got the linear servo. Yeah, it'll be point.
Choose your phone.
And cheap. So that's my project for this week.
I didn't bring a plug in. Should have like a 3 hour battery. Okay, it's powered up.
Oh, sure.
Okay, just while it's coming up, because everybody wasn't here when I talked about this the first time. I had this sump pump. I had a sump pump problem, and I figured out that it wasn't the sump pump, it was actually the switch. Last time I couldn't remember how I knew. Basically, the sump pump plugs into the switch. So if you plug it in directly, the sump pump would run. But if you plugged into the switch, it would, the little ball float switch. So then I decided I was gonna put an Arduino in just because it needed to be done with an Arduino. And I had a temporary setup for, God, actually probably a couple of weeks, and then I ordered a float. But then I decided that I want to use something small and get a little bit fancier. So I put a Wemos D1 Mini. That was the basic controller, and that worked. And it has sensor, and it turns pump on and off based on the water level. And then I decided I needed to put this on the web. And now it's on the web. In a previous session, I talked about how I did the Wemos software and the web service, and I'm just going to give an update because what I could do then is I could just do a get with using the web service. And now I have 2 pumps actually running. One is the main sump pump, and another is in a wheel well that's like one of these 5-year window well. It's one of these 5-year things, like when you have a flood, every now and then you sort of get water in that window well. And it's in a corner of the basement. So I put a pump in that. I don't expect it to. It's not going to happen very often, but since I'm doing this, I put one there too. So I have 2, and they both report to the web. As usual, I have to do a tribute to PowerPoint.
I did not have the book.
And I also need Chrome. For that, make sure I get the right PowerPoint. So Westchester update. And all right, sometimes I remember and sometimes I don't. Now what do I need to get this thing?
You need to connect to automation technology.
Oh, okay. That probably did that automatically. Okay, automatic technology internet access. So I got that.
Okay, and then let's see. Probably the easiest way is go up here and go to cast. There it is, right there. Yep. And then you do the pull down.
You're doing the whole desktop.
Yeah.
Yeah.
Yep.
So do the bottom of desktop,
And let me just share it.
and it should come up. Capturing desktop, it says. Still says that. It's working. I wonder where it went to. Let's try the pull down again. It's having issues.
Capturing desktop.
You click share.
Were you running 24 volts or were you running 12?
24. I ran 12 till I got 24 today. Then I ran
What's
Oh, I
your
got it.
motor rated at?
24. Some of the notes say it'll run at 12 or 24.
It'll probably run at 12, just lower.
Oh,
You
okay.
won't have the,
Share
Wait
entire
to-
screen.
well,
Get a Russian or something.
we were talking about that.
There you go.
Okay. All right, so now I said a good part of what I wanted to say, but let me say it again. Okay. I have two control devices displayed, both control sump pumps, and they report to the grid. And what I've done last time I was here, they weren't reporting. So got that working. And I also got a page that I can display the status. And I have some other things that I want to do. Okay, this is what it looks like again. And with the one that's used for the regular sump pump, it fits actually into a box, I mean an outlet box. Now, just to say other things that I'd like to do physically, I like to get rid of that outlet because it's big, takes up a lot of space in that box. The other thing that I need is a power supply, a small power supply. I got one of those supplies. Viewer sent me a link to this place down 75. Yeah, those things cost like $1 and something a piece, so I bought 10 of them. So I use that as a power supply, but that's much bigger than it has to be. So eventually I want to find a smaller power supply to shrink it, and I also want to have something a little smaller than that. Okay, this is operationally what it looks like. There's a Wemos D1 Mini. What did I do? I'm gonna go back. I went to the end. Okay, here we go. I'm not touching too much. All right. The Wemos D1 Mini is a processor, and it has the pump control in it. And what it does is I have it like poll every 20 seconds to see if there's water. And I continually just run the pump independently. What I do is I count the number of cycles, the number of 20-second cycles. And when I get enough to actually report to the web, it reports to the web every 15 minutes. I mean, that's variable. You can make it, whatever interval. And 15 minutes, I'm discovering is probably too often, because right now it's kind of like a dry season, and it runs about 20 seconds in a half hour or so. And I know during the wet season it runs a lot more often. And this, this is autonomous. This is going to run no matter what. And then every 15 minutes, it does a post to the internet to tell a web API or web service what's going on. And what that web service does, it just does an insert into a database. And it's just a write to the database, and that's all there is to it. There's some trickery that goes on with the Wemos, though, and when I finish this, I'll show you what that is. This web interface is sensitive to the amount of data that you want to push through it to the internet. And you also want to use arrays, character arrays. Can't use strings. Both the processing time and the amount of space that you use, it'll just crash that what's the thing called? Library. It's a library function that you use for the Wi-Fi function, and it's kind of touchy. Another thing that's touchy about this is if you try to do this too often, you're going to crash the website. And a lot of times, this was just a lot of the hangout. The website crashed. I had no idea. And then sort of slowed things down and started working almost all the time. What I just put in is a previous. I just put in a page, just a single page that does a query into the same database. Now, both of these work on this same web server, but code-wise, they're independent. So this is, ooh, I should stop touching this. All right. The web API, they run on the same web server, uses the same domain, but they're completely different functions. This website query thing here is just like a website, like any website, common website. This web API is a little trickier. And if you're into web APIs, they can do a post, they can do a get, they can do a put, but they do just very simple functions. And at the end, you want them to either read something from a database, write something to a database, or modify some stuff to send a database. And it's just really straightforward. Again, once you get past all of the little kinks, it really is straightforward. But like anything, it's kind of a learning process. So now I have the query working, and what I'm going to show you is that the results of that query today. Let me go to the next one. What I'm going to do after this is, once you get this stuff on the web, you start thinking about stuff that you can do. Like if the pump fails, I knew I would have to put another sensor in there for failing. But what you want to do is send some kind of a report. You either want to send a tweet to Twitter, or you want to send an email, but you want to be alerted that something happens. And the thought is that if you can do this with this kind of interface, you can hook it up to your burglar alarm, and you can be notified that something happened there. Like instead of remoting this stuff to ADT, we'll just send it to my phone, and that would work. And so kind of the next thing I'm going to work on is the email trigger. It's not as bad as it would seem. My problem is I don't want to spend money for a control. For .NET, they have these controls, and you populate it, with the text and the subject. And it's not like you're writing a whole lot of new software, and it actually can send your email. And on one of my other servers, I actually have this thing there, but I'm trying to figure out how to do it without spending $200 for this, piece of software. Okay. That becomes another thing when you get into this stuff that you want to do, is just not spend money. Why am I dead?
System.net.mail.
Yeah, there's quite a few of them out there.
No, that's in Visual Studio. There's, that's the include. It's going to go into your program.
So that's a control that's already there.
It's free built in. All you have to do at that point is fill in some of the supporting information, like who your email service is, your email address, your password, your MX record, some other stuff. And then after the core information is there, then you build your email structure, message, name, and then just send it.
Yeah. That probably works the way those controls do, but I never used that one. I know probably about 5 years ago, there was a control that I bought, and it was just very easy to use.
Do you have the whole Visual Studio, or what do you have?
I have Enterprise.
Visual
Studio
Enterprise.
2015. I have 2017 too. This computer has 17, but I have 2015 Enterprise. As a teacher, this is the kind of stuff that you get from smartphone.
Okay.
Download it, use it.
Yeah, it should be built into your system. It might not be as easy as other controls, but it is.
Now, I'll have to go to that one. Now, what do I want to do? I want to do Arduino.
Somehow or another, you kick yourself off of the casting.
Okay. So let's go back to Chrome.
Go back to cast and then
And cast. And
try it again. So do the pull down on the top. Desktop.
desktop. This is what happened before. Just froze.
Well, try to see if you could.
Oh, entire screen. Okay. Share. No,
Try the other one. Try to share the folder first and see if it likes that better. It's weird.
Doing something. Let's try it again. Now, if I do a tab, I'm not going to be able to show Arduino, right?
Correct.
So it needs to.
See if I can kill it.
It needs to go with the program.
No. I'm gonna try to shut it off.
Okay.
I can't get to it. I can't get to it either.
This is the
I have to IPL it. He's gonna IPL the Chromecast.
Okay, failed to attempt.
We just rebooted it. The Chromecast is alive. So
It'll probably take it a couple seconds to get back on the network. I've not had this problem. Not with the Chromecast. It's usually the router. We may have to kill the router.
let's see. We've had issues with the routers before, though. Even your good router.
So it's up, right?
Yeah. Cast aspersions at the Who2 router? Are you kidding me?
You having any luck?
No, click it again. Okay,
Somebody did something. That was me.
that was you?
Okay. So you're able to get to it.
That,
It's probably sensitive because you're trying to connect to it with a microphone. It is Google, you know.
this is Chrome, you know, so.
Frank, I just looked up, how to send mail from vb.net or c#.net.
Okay,
It's 23 lines of code. There's no special.
okay. Yeah.
And,
Can you send me a link?
oh yeah, not a problem.
It's probably SMTP, right?
It's
Yeah.
it's called system.net.mail,
It's a client.
and it's you include that or import that into your solution, your project for vb.net or whatever.net. And literally, just like I said, it was, who it's from, your network credentials, so your username and password to use that provider. Your host is gmail.com, smtp.gmail.com.
I'll probably use my own.
Yeah, well, whoever yours is, because you're gonna have your mail provider, your username, your password, and that gets you to their system. Then once you've got permission to be in their system, then you just create an email. So it has like the new mail message, who it's from, the 2 addresses, the subject, the body, and then you give it a function that just says send the mail. And I would say a third of this is a try-catch component. So you can catch it if it fails, and if it fails, you try it again.
Using Microsoft Word.
Okay.
You were almost there.
Midas Touch. Okay,
You were almost there, Frank.
all right. Get the Midas Touch. So let's go to which one do we want to do? Frank, update 1 or 2? Update 1. The key to all of this stuff is there is a library file, restclient.h. And it's not perfect, but it is the best thing that's out there right now. And it has the functions that let you both do the Wi-Fi and actually do the post or get whatever command you want to use to send to the web. You will see here, and I might as well explain this. When you want to send data, you have to put it into a character array.
You're making a JSON string.
Yeah. Now, if I did it just like this, it's of sufficient size that everything will get passed and everything will be fine. That's no good. What you need is some variable data. Like the variable data that I want is a duration. And when you do the duration, you have to do a concatenate. Somehow when you do a concatenate, it sort of expands into more space and the Wi-Fi just crashes, you know. So kind of the tricky part was actually down at the point where, all right, so what I do is I just set the array up with part of the data, because some of it I want to be the same. And then I have to do this is called, it's a concatenation function for the Arduino devices. And what it does is it takes some variable data and it concatenates it onto that main array that I had set up. Now, so you can only concatenate an array to an array. Now, with some of the bigger processors, you can do all kinds, have functions do all kinds of things with strings and arrays, and it's just very fine. That's just not the case with Arduino, so you have to jump through some hoops. And what you will notice up here is I create this temporary array, and it's of size 4. And then I take an integer, which is water duration, and I convert it to a string. And that's done here. Then I take, this is where what is happening here? Okay, the integer is converted to a string right here. And then I run this function to set up an array, or to actually get the string into an array. This 2-character array will put the string data into an array. And then what I'm going to do is do a string concatenate, which is going to add the original array, or add the new array onto the original array. And so now I got an array at this point that's got everything in it that I need to send to the internet. And this is the main function, which does a client.post. And what's in it is, this is the folder on the web server that holds the web service. It's /API/home. This is the array, and this is a pointer to a buffer that I can get the response. This is the actual command that sends everything to the internet. This is the actual command that crashes if stuff is not right. And then the rest of this stuff is just sort of printing a response to show that everything worked. The rest of this stuff is just managing the pump, turning it on and off, and counting. Like you can notice up here, I count 20.
Wait, go back down.
Okay.
If you would please. Right there, you basically declare your integer status code, and then you give it a value. 2 lines right below it, you're printing status code without formatting it first.
Okay, this is just for your console. Like, okay.
Oh, yeah, okay.
This is for the console. This is for debugging. Like, once you get everything working, you take all this stuff out. But when you're debugging, everything.
Set your debug off.
Yeah, you go up and you can tell how far the thing got. And you can tell what it crashed also. And when things work, you take all of that stuff out, because it actually just uses up CPU cycles, which is not good. But you needed to get there. The rest of this is kind of trivial. I mean, it really is kind of in examples that they give you. This is the kind of stuff that's in the examples. And it's just a loop where you keep checking to see if the value is below a certain point, sensor value. If it's greater than 750, I don't have any water. If it's less than 750, that's the case where there's some water in that well, and it turns on the pump for 20 seconds. 20 seconds is just enough. That's just the amount of time that it takes to pump it out. It has about 2.5 gallons of water in and you could let it capture more, but I let it get to the point where about 2.5 gallons in there. And then it runs for 20 seconds. I'll pump it all out and it'll stop. And then when it comes up again and touches the sensor, it'll run for 20 seconds again. You count those 20-second intervals, and really that's how you get to the 15-minute interval. I say 45 times with the cycle. Now I'm going to send a report to the internet. So that's all there is to that. So now let's look at the page on the internet, which reports. I'll put this in. Okay. You'll see that I put this text box in here in this label because I'm going to do an SQL function so that I can calculate how many gallons of water were pumped in the last 24 hours. I keep thinking about a lot of things like this that I want to do. Some of them is just to see if I can do them, you know. But this shows you Q pump. Q pump that's the main pump, and the last time it reported was 6:12, and it hadn't pumped any water at all. And then it pumped again at, well, you can see 5:57 before that, there was no water. At 5:42 when it reported, it had run for 20 seconds, which meant it just pumped it dry. And so I have two pumps there. One is W well, and as I said before, I really never expect to see any water there. This is when a flood condition. And I have at the back of the basement, I have a winter well. And you know, when things really get bad, that thing will fill up with water. And if it fills up with water, you can get some in the basement. But it doesn't happen that often, but you never want it to happen. You know, so I'm also monitoring that one. This doesn't really help, but you can do sorts. This is something that Visual Studio can give you. Like this is the control called a grid view. You drag it onto the screen. You populate the table that you want and the fields that you want to see, and the thing will fill up with data. This is actually one of the good things about Microsoft. Microsoft does a great job of displaying data. And with some other language, you just have to write all kinds of stuff. This thing will sort automatically. If I want to sort by current date, right now it's descending. Now it goes back to ascending. And so this starts with 818. Go back the other way. If I want to sort by the pump. And I've had some other, what you see here is I had some other ESP, well not ESP, but Remos E1 sensors running, but it just sorts them by the name. And if you go the other way, this is just, it's a coincidental thing, but I did nothing. I mean, I essentially did nothing to make it work, some check boxes, you know, and it's one of those good things about Microsoft. Same thing with the pages, like it's paginated. And again, this was just one of those things that you do a checkbox and you get it. So I got this report now, and it's not terribly useful except for by time. I can kind of look at this thing and I can see when the pumps are running and how often they're running. As a matter of fact, once I start doing this, right now, you know, it pumps about maybe 5 gallons an hour or something like that, which is not a lot. It's not as much as I thought it was pumping. And during the wet season, it does pump a lot. That thing is running all the time, you know, but it's just not as bad as I thought it was. The last thought that comes from this is that if you can do this with that pump using one of those microcontrollers, you can use it for almost anything, you know, and you just report to the web. And once you get it on the web, Ray was looking up that web email function, and you use that, send yourself an email, Or if you want to get fancy and get the Twitter thing, because that's out there too, you can send yourself a tweet. I was telling somebody, this was like 3 weeks ago, I tweeted for the first time in 5 years. I mean, I hadn't tweeted in 5 years. And when I was at this conference, you know, at this table, and it said, send a tweet out to say that you were here. So I sent a tweet. I actually don't have a lot of use for Twitter, but this might give me a reason to send a tweet. Okay, so that's probably it. I have some other sort of grand plans for this stuff. I'm just playing with it and seeing what else I can do. This only thing I want to do, main thing I want to do with this physically is shrink the physical size of it, because it works. There's some problems. We were sent some email about the contacts, you know, may not take the hit, you know, it's a half horsepower motor.
That was Jim.
Okay, well,
Yeah.
so far.
It is. Oh my gosh.
And one of the things you can do with this, you can kind of figure out, this is experimental, you know, just if it does kill the relay, or if the microcontroller hardware can take it. So far, the microcontroller hardware has been very, very reliable. The other thing too, you know, I at first I thought I was going to have to use antenna with the Reno's microcontroller. The one that's in the window well is actually about 30 feet, and it's actually outside, and it still picks it up. I mean, from the router, it's a long way from the router. And when I tried this at the school where I teach, it didn't work very well at all. But it seems, for whatever reason, it works a lot better in my house, and I don't think I'm gonna have to use any antennas or anything like that.
Is it line of sight, wood walls?
There's a wooden walls. It's like it's back there. There's a wooden wall, and then the router is over there, and there's another wooden wall. So the two wooden walls, and
Compared to metal siding, concrete walls, what's the differences from the one building to the other?
you mean my school?
Yeah.
I have no idea.
The school probably has a lot of metal in it.
Probably has a lot of metal in it. That probably.
They have rebar in the concrete walls. That's
Yeah.
one thing.
Yeah.
Like a cage.
But I'm sold. The only thing is I'm suspicious about the processing power, because, you know, if you try to send too much data across that Wi-Fi link, it crashes. So it may be processing speed, maybe buffers.
It shouldn't be doing.
Where it does it, and I don't know why yet. The thing that you can do anyway is you could probably break it up, you know, and it's one of those things. I don't know yet. Actually, I don't even know how to figure it out. I mean, I don't know how to figure out what the limit is for the size of the array. I know when it goes, I know when it crashes, you know, but I know if I don't use this concatenation function, which I think is just allocating more space, that I can get more data. I can send more data out. But this is kind of like some of those nitty-gritty things that when you're doing a regular, you know, a PC or something, you don't even think about it. You know.
You might want to use concat and then use an extract to extract your string if you got an extract.
No, this is just to get it in the shape, sort of JSON format, so that you can send it out. On the other end, there's no problem. You know, on the server end of it, there's no problem at all. So it's going well, and like I said, I'm trying to send some email and try to do some other calculations and make it small physically, and then I'm done.
I have an idea for you.
What's that?
Once you've concatenated it into a certain string or character array,
Yeah.
once you identify the length of the string, length of the array,
That's a good idea. Once I've gotten everything in there.
then you dim or create a new string with that length,
Exactly that length.
populate it into the string, then send it out from the new string. That way you're not doing function inside function inside function.
Yeah.
You're sending just the string contents.
Well, actually, what I'll know is, you know, I was talking about, well, I don't know the limits now. I'll know what the limits are, because I can just look at the size that works and then the size that doesn't work.
I ran into a problem. I stayed up working all night on this problem tonight. And in VB.net, because you're in the PC side, it actually tells you can't do this because I had too many structures inside of a structure, inside this, and it ended up saying you can't do that. Inside the Arduino environment, I don't know that it has enough intelligence to say you've got too much going on.
No, it's not going to tell you.
So it just crashes.
It just crashes.
So if you start adding strings, add this piece, then add this piece, put it into the next element. But you build it all together, then see what is the length, put it into a new component, and then send from the new component. You're simplifying as you go.
Arduino does not handle strings well at all.
Yeah, actually, this is why you have to put it into a character array. Yeah. But even with character arrays, it doesn't tell you messed up.
Well, if you reserved enough space.
If you reserve too much space, it's definitely going to crash. So I started out
it's because it's
200 characters.
It's going over a page border or something like that. Yeah. But if you reserve the space,
I mean, the ESP8266 has like
4 megs.
At least 20. No, that's the flash.
That's the
20.
flash, yeah.
At least 20K of RAM.
At
not
least.
more.
No, they should have.
It should have the space. That's not a problem. But it's just how you're using it.
And it could be that library function.
My brain doesn't work sometimes. And sometimes my brain doesn't.
And that's part of the reason I hate these libraries, is because you never know what did they declare in their library. Did they give you enough space?
That's why there's source code.
Yeah,
but that's
no,
well, which library are you using?
Okay, it's REST client.h.
REST client. Okay.
Yeah.
It's hard to do this on the phone, but
yeah, it is. I see people do stuff on the phone. That's why we have laptops, we have tablets, we have phones. Some things are hard. Like one of my kids in my camp does PowerPoint
That was not the right
on a phone. And I always say, just because you can do it doesn't mean that you should.
yeah. Well, I mean, well, so
some of them want to code on the phone.
There are different, multiple REST clients.
This one is REST client.h, and I think that one is unique.
What about you're trying to create a JSON string? What about just using a JSON library?
I could do that, but
yeah, it's a lot of overhead. I mean, it'll work because I've used that library on an ESP8266.
This just happened to work. And actually, I started going to use that JSON library, and you start going down the rabbit hole. Let's go back and make something work here. There are a lot of things you can do. It's one of those time things. I know that if this were some other, like if this were something by Microsoft or somebody else, it would be more robust.
I think the way I created a JSON string was more or less how you suggested doing it, just making it individually and
building it slowly.
Building it.
You can do it all at once with an SPRintf. I mean, that's the C way of doing it.
I don't know if that's supported.
Yes, it's supported.
Okay. I haven't got it.
But
and actually, it might generate. I look at these things as being primitive because I know a lot of the stuff that works in a regular C and C++. You don't even think about it because most of the time you try to do stuff like this using strings. And
well, there are two different kinds of strings. There are C strings and then there are C++ strings.
But
C strings are just character arrays.
Yeah. This is C++. So it would be C++.
Well, but you could use either. I mean, you're using regular C strings. That's what the string cat is, a C string function.
It supports the string data type.
Yeah, and it also does the C++ string data type.
Do you see? Let's see. What is this thing? REST. I can actually usually find this thing. It's on the machine.
Is it uppercase
It's
Rest.
uppercase R,
R and uppercase C.
uppercase C.
Yeah, I think I found it.
Yeah.
But it's hard to read on this small phone.
How have you been? How you been? You good?
And you're doing a post.
Working with
Yeah.
stuff. I am posting the Google Plus.
Is this the one?
Page, what are you doing?
It's the Arduino. Yeah, that one.
Here, you want to just read it on that? Would it make your life easier?
Seriously doubt. I mean, it's based on they're using pointers, so I don't think there's any particular, there's no fixed length, maximum length.
Last night was saying,
Yeah, it's just, they're just character pointers.
Oh, okay. Yeah.
It actually it does both C
You
strings
put like
and
sponge or rubber in
C++
there?
strings.
The ones that you use with the Windows and the
Yeah.
screens, they are very,
Squishy.
yeah.
Yeah, I don't know.
It goes with the sensor aside.
I've had problems with using strings with
Already made the sensor.
the Arduino IDE too.
And I have read that other people have trouble strings,
String,
which is why they tell you to use the character arrays.
Perfectly.
I don't like how it handles strings at all.
The problem is mixing the two is difficult because the way they're stored are completely different. And so you have to be careful. I mean, I think there's a function of the string class to convert it to a C string. And you have to make sure you do that if you're moving back and forth
Yeah.
between them. So.
I don't know. I know I've had problems with strings before. And
Yeah,
most of my
if I
solution is
take
just
range
split
Q
it
and I
apart.
start doing the size of,
I almost
I can
never use the C++
tell when I'm sending out.
strings. I'm an old C programmer, so I do everything in C, unless I have to use a C++ data structure. So anyway, yeah, I'd have to play with it a little bit to see. I mean, it shouldn't be crashing. That's for sure.
it crashes, it actually crashes the Wi-Fi. It's not necessarily that library function, but the Wi-Fi just crashes, it resets.
Huh.
It gives you on this week. Dumps.
All of it is,
And then it
it's the
starts
watchdog timer
Yeah,
reset.
Wi-Fi
There's
can
probably,
fire
it says WDT somewhere in.
You bought the.
I've had that happen. Yeah,
the
it's the whole
insert.
processor crashing.
Yeah, I've seen that a bunch of times.
They have something called a watchdog timer that if the
Yeah.
processor doesn't reset it and clear it often enough, then it resets the whole processor.
Without the use of an Arduino.
Yeah.
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 Okay, so once I send my email,
The components in one side are important.
You know, you can send email
A,
from an ESP8266.
all right, and why would I do
I
that?
just bought a Pi Nano.
Eliminate
Pi
the
Zero.
website. You know, you can store all
Yeah,
your
I know you
data
can. This is all- I'm
in
just-
the
I'm just
flash,
thinking that it's
or a
gonna
lot
be-
of your
It's
data.
gonna be
Yeah, last week I
much
bought
easier
a
to send
Pi
email on
Zero.
a web server.
With Wi-Fi
Start thinking
built
about
onto it.
something like that on Arduino.
The Zero with Wi-Fi built in. I haven't even started playing with it yet.
Or you can store data in the flash too.
Actually, it's got a lot of space to save.
Yeah.
And theoretically, you know, this thing's fast enough, so you think that you wouldn't have any CPU problem.
You have, it's a very fast processor.
But it's like a
Considering
hotel elevator.
No, it's able to do a lot of stuff, because the stuff that we usually do.
you got it set for what is that, 160 megahertz or the 80 megahertz?
The car inside it itself.
Either way, it's way faster.
It's
than
way
a regular
faster.
Arduino.
It's fast.
Yeah. And it's got a decent amount of RAM, unlike an Arduino.
and a lot of flash space.
I'm doing everyday things.
Yeah, I'm not running, like if I compile it, I'm not running out of
How are you
space.
gonna identify each floor? And
I think there's even a way,
I will use the ultrasonic,
I might be wrong, I think there's even a way where you can store a program
to avoid all the
in the
wiring.
flash and call that program from another program.
Well, it's
No, you can read stuff in file system. You can store it on file system. You can read it, and then execute.
Sound effects.
with the wire, and use the
Okay,
to
so
host all the ultrasonic.
that's my story and I'm sticking to it.
I need to check it because it's
I like your story.
Okay, I know what else. I bought
I think
a,
it'd be better off to use
what did
an
I buy?
optical encoder for each floor.
Tell you what, you're
Use an
gonna, see if you
optical
wanna
encoder.
keep it first.
Okay.
Yeah, I'll keep it. I'm a little bit like Leroy. I never saw this thing that I want.
Did you play around with
Yeah, I
it?
didn't mess with it. But I will.
Oh, okay, thanks.
You got my notes and stuff. Yeah.
I got your notes.
About ready to take that thing and just go smash.
You gonna buy something else, Leroy?
But you know, theoretically, that thing will take care of my garage door.
You already gave me money for that.
I
I already bought stuff.
I have a garage door opener, Arduino, that can, from the web, I can open and close 3 doors plus 1 light. And with one of those, you know, it can take care of,
Lighter.
what I have now is like this size.
Yeah, and it's
Yeah.
small.
If it works.
That's why,
If it works.
that's why I thought you would like it,
No,
because
if it works, you know, that'd be great.
when I saw that, I said, oh, that's perfect for Frank. Frank will just eat that
I'll
up.
tell you, actually, this has been like 2 years now, and I'm running these garage door opener motors. And it is,
No
the same
problem.
relays, no problem, no problem at all.
Yeah,
Well,
but
you're not-
you're not citing
operating.
it very often.
No.
You're not driving the motor directly
Not big enough.
either, but yeah, that's good.
There's not enough material in order to get onto the shaft.
Yeah, I'm driving a relay, which is driving.
Right.
Yeah.
So the current to the coil and the relay is pretty tiny, so.
Yeah.
It's,
I'm making all.
eventually it will, but it's a lot less likely to weld the
I'm
contacts.
doing my work.
And if it does, you just replace it. It was cheap, replace it.
And a couple dollars.
In the Japanese style. All
Do it again.
the stuff on the-
It's gonna take
Okay.
sauce, just for fun.
10,000 hours before it does something strange.
Yeah, when you do something like the sump pump, I've been reading, like, what fails first? Those pumps are really not cycling that often, so they should last at least 5 years. And the switch should last longer than that, but this last time it was the switch that went bad.
I use a lot of sump pumps, they just go bad.
Do
And
you check whether it's the switch or the pump?
it's the
Because most times I just
switch,
replace it.
a lot of times it's the switch, the impeller, I've destroyed impellers, I've melted the hub where it connects to the shaft, melted that because it's a plastic. So now the recent one I got is a metal impeller, metal hub, and a higher quality switch and a lifetime guarantee pump. So I'm
So how long do they usually last? For me, they usually last about 5 years. It's
less. I've been there 17 years, so I'm pissed off that I've gone through 6. But
Okay.
I have 2 of them in my well. My well is giving around 7 feet deep.
You got a lot of water.
Yeah, I do. We do. I want to make sure
Mine is on every minute, all year long. It's like I'm in a lake or something. It's working all the time, all the time.
Yeah, well, one of mine has a sensor up here, and the other one, the sensor's down here. So if they both kick on, it's shit hit the fan, and it does that quite often.
What?
This is what I am planning to do in the wall with the spray, glow in the dark paint
Oh,
and servos to put the time in the
you're
wall.
gonna do the time like
I'm
that.
doing that. With, you use a blue laser for that, or UV also.
That's cool.
Actually, UV is more appropriate, yeah, but it's hard to see. if you
I
want to
killed it.
play with it.
You killed it. That's cool.
I figured that'd get folks into his attention.
Well, I
You
sent
killed it.
pictures of to put a laser in the robot in the center and to paint all the floor with the glow in the dark painting.
I don't know if, I don't think I saw that
To
one.
trace all the movements of the robot. In the dark, just.
That's funny. What laser are you gonna use to do that?
Blue one.
Just a blue one? And that way it basically glows for a certain amount of time as you're going away. That's fun.
I didn't see that one. I'll have to go and look.
Because there is no place for a pen.
He's got some good ideas we ought to steal.
There is a place for a small blue laser in the center. It's easy.
He's got some ideas that we ought to steal for our robots.
He thinks way up here. I'm still thinking way down here.
I just want the core code working and the assembly instructions.
I sent a video about the laser and the paint. I tried the spray painting.
Yeah.
I missed that one somewhere. I'll have to.
Wood panel with one.
Somehow I missed that one.
Then cover 1/3 and another application, and then 2/3 to see how it changed the. How do you say?
Luminescence.
No, but
Bright.
how long will stay the trace?
Persistent.
Making experiment, but I found a new spray that had the double of
Effects.
luminescence.
Okay.
That cost $14 in Menards. It's double than the standard one. But I need to I need to solder the. I already I will use the nano board that is used for laser engravers. That they have it's a you put a nano in it and it has 3 drivers.
Oh,
It's
a
the
ramp
drivers.
board?
Huh?
A ramp board?
It's used for 3D printers, not lasers.
No, it's used for laser engravers, just 2 dimensions. The chip kits that come from China is a frame of aluminum,
Okay.
and it has the nano main board or something with 3 stepper motor drivers.
Okay.
You move the
It sounds like a ramp board.
the third one is not used
During process. It's only used
on
between the
the
projects.
laser.
Oh,
But you can use it on
Something
paper.
very
and
similar to it.
Just for grading.
sorry.
It's 500 milliwatts.
I don't see it.
laser.
I don't.
Yeah, there's
I
some
missed it
lasers we have to
somewhere,
tell
and
people
I'm
we're
still
not gonna
missing
fix
it.
that.
No.
We're not gonna, we're not even gonna bother with it. And we had a guy recently bought a used laser off of eBay and
Oh,
it
did he?
didn't work and he brought it to us wanting me to repair it. He bought it used for like $250 and even knew it was only worth $1,400 and it was,
The
Piece of junk.
stepper drivers cost
Yeah.
70 cents.
You get what you pay for.
oh yeah, Carol, she's like, oh yeah, Ray, this is the one that you had the employee just tear the old ones apart. I literally bought 3 of them from my customer. He owns 9 of our lasers. I bought 3 of them just so my customer would stop bitching about them.
Yeah.
Because they were junk. And he's like, oh, how do you fix this? I don't want to talk about it no more. So I bought them as scrap parts and I've sold the power supply, stepper motor. I got, half my money back. I still have,
This is the box.
Yeah, you could, this $200 bargain, spend $1,000.
Access.
It'll get running, but that's what it costs to do.
yeah, those things, they're very
Very,
inexpensive and they're very
Yep.
cheap. And it's because
They
that
break
Chinese manufacturer has cut every possible
every
corner
corner.
to
So you
get to that price limit.
Got a lot of
that the price
failures
range.
built into the design.
It's not built into the design. It's deficient. And that's why
Deficient, yeah,
why it's failing.
they run on the edge.
They have a big surplus market also. they find parts. You can buy full boards that cost less than the chip itself sometimes.
Yeah.
There is no explanation.
I've got a couple boxes of scrap parts for lasers. Lasers. Now,